Hello everyone! Once again, we're inviting you to join us on another thrilling and wildly adventurous journey. Our destination this time is Europa. It's one of the strangest and most fascinating moons orbiting around Jupiter. Europa is especially famous for having an ocean beneath its surface, so chances are you've probably heard about this bizarre world before. Some scientists even believe there could be actual life forms thriving inside that hidden sea. But what would happen if you tried to stand on Europa's surface for just 5 seconds without wearing a spacesuit? And is it even possible for someone to swim through the ocean beneath its icy crust? Welcome to our channel. We're glad to have you along for the ride. Let's dive in and uncover the incredible story behind Europa. Alright, it's time to blast off. A world of ice and ocean. From outer space, Europa might come across as a dull and unremarkable little moon. Among Jupiter's 4 Galilean moons, Europa is the smallest and the second farthest from the planet. It's only a bit smaller than our moon, but it weighs in at just about half the mass. That difference comes down to how these two celestial bodies are built on the inside. While the moon is mostly made of solid rock, Europa's interior is packed with much lighter materials, mainly frozen water. Europa completes one full orbit around Jupiter every 3.5 days. Like many of the moons in our solar system, Europa always keeps one side facing Jupiter as it revolves. That means from just one hemisphere, you'd be able to gaze up at a giant striped planet glowing orange, with the great red spot staring right back at you like a massive eye in the sky. Europa's orbit is almost a perfect circle, and it lines up almost exactly with Jupiter's equatorial plane. But in astronomy, words like almost carry a lot more meaning than you might think. The differences between Europa's orbit and a truly perfect circle, or its alignment with Jupiter's equator, are tiny enough to require precise instruments to detect, but they're still very real. And it's those tiny discrepancies that give rise to powerful tidal forces. In other words, whenever Europa gets a little closer to Jupiter, it gets ever so slightly stretched out. This slight deviation from a perfectly circular orbit is one of the main reasons Europa has remained so geologically active for billions of years. The second key reason lies in the gravitational interaction between Europa and other Galilean moons. The 3 large inner moons, Io, Europa, and Ganymede, are locked in a synchronized rhythm as they orbit Jupiter. For every orbit Ganymede completes, Io goes around 4 times, and Europa makes a full trip while Io orbits twice. As the closest of the big moons, Io experiences the strongest tidal forces from Jupiter's gravity. Through this gravitational tug, some of Jupiter's rotational energy gets transferred directly to Io. Io then passes that energy along to Europa and Ganymede, thanks to their orbital resonance. All of these effects working together constantly stir Europa's interior and keep it warmer than it would otherwise be. Without even one of these crucial factors, Europa probably would have frozen solid eons ago. Its mass alone simply isn't enough to sustain a subsurface ocean for billions of years on its own. Any sufficiently large celestial object begins its life with a hot and molten core. That intense heat is generated during the process of gravitational collapse, as the object is still forming. But the smaller the object, the faster it loses that internal heat as time goes on. Alright, now you've got the key facts you need to understand Europa on a basic level. And with that foundation in place, it's time to move into the most exciting and important part of this video, our thought experiment. So let's head out to the Jovian system and begin our journey. A radioactive wasteland. So, what would actually happen if you tried walking across Europa's surface without wearing any protective gear at all? First off, this icy moon doesn't really have anything you'd call an atmosphere. Because of the sun's radiation, the icy crust, made mostly of water, releases small amounts of hydrogen and oxygen, but it's nowhere near enough to form a proper atmospheric layer. The surface pressure on Europa is literally trillions of times lower than we're used to on Earth, basically zero, almost the same as deep space. So the first thing your body would experience isn't just low pressure, it would feel exactly like you were tossed straight into the vacuum of outer space. Your body would noticeably puff up, making you appear weirdly bloated and way bigger than usual. If there's any air left in your lungs, it's best to exhale right away, since it could expand and tear the delicate tissue inside. For the same reason, you must keep your eyes tightly shut. The fluid in your eyes could start to boil and the surface would dry out instantly, causing some seriously nasty damage. The second major threat on Europa is the brutally low temperature. Even at the equator during the daytime, it never gets warmer than 110 Kelvin. That's a bone-chilling minus 261 degrees Fahrenheit. Surprisingly though, your body wouldn't actually freeze solid. That's because a vacuum makes for a surprisingly good insulator, and heat from your body escapes only very slowly. Still, your skin and any exposed membranes could end up suffering severe frostbite very quickly. As terrifying as the vacuum and freezing cold are, neither one is likely to kill you in just 5 seconds. You'd definitely need a doctor and probably a hospital stay, but you'd most likely survive the ordeal. You wouldn't even have time to develop altitude sickness like mountain climbers do at extreme heights. 5 seconds just isn't long enough for that kind of thing to kick in. But when it comes to danger, both the cold and vacuum fade into the background, compared to Europa's biggest threat, radiation. Europa does have a magnetic field, but it's so weak it can barely deflect any charged particles at all. Meanwhile, Jupiter's magnetic field is absolutely enormous and incredibly powerful. That massive field captures particles from the solar wind and funnels them into intense radiation belts. Earth has radiation belts too, but Jupiter's are much larger, far more widespread, and way more intense. One of those belts happens to intersect directly with Europa's orbit. As a result, Europa is blasted by environmental radiation that's roughly 1 million times stronger than what we experience on Earth. The daily radiation dose on this moon is about 5.4 sieverts, more than enough to cause severe radiation sickness. You wouldn't get sick in just 5 seconds, but dust from Europa might settle onto your body or belongings during that short time. That dust can become activated, turning whatever it lands on into a low-level source of radiation itself. So if you skip proper decontamination after strolling across Europa, you might suffer some incredibly unpleasant and potentially dangerous consequences. But in the end, all these risks are basically pointless. Europa's surface is a bleak, featureless wasteland made up of icy plains stretching all the way to the horizon. There aren't even any cliffs or mountains rising higher than about 300 feet. Sure, there are some strange formations here and there, but they're easier to examine from above than from the ground. So really, it's best to just give up on the idea of going for a walk across Europa's surface. That said, swimming in the moon's legendary subsurface ocean might just be worth it. Imagine the thrill of meeting a totally alien swimmer, some kind of xenodolphin, gliding through the dark, icy depths. Into Europa's ocean. First of all, reaching Europa's hidden ocean is an incredibly difficult and complex challenge. At such frigid temperatures, the ice becomes so solid it's as tough and unyielding as granite. What's more, scientists still don't know for certain exactly how thick the icy crust actually is. Some researchers believe it could be dozens of miles thick, forming a nearly impenetrable barrier. Under these conditions, trying to swim beneath the ice would involve dangers that are beyond anything you could imagine. The pressure alone would be so intense, it could easily crush your body in an instant. On top of that, the water down there might be incredibly hot, and that could result in serious, possibly severe burns. Some alternative models suggest that Europa's crust could actually be much thinner, just a few miles or even a few hundred feet thick. If that turns out to be the case, then diving into the ocean could actually be a real possibility. But even then, it's pitch dark, it's freezing cold, and you absolutely cannot breathe. At the end of the day, you're still a human being, not a fish built for underwater survival. That said, while spending 5 seconds in total darkness wouldn't be pleasant, it wouldn't be lethal either. But from the perspective of Europa's ocean itself, contact with humans could be extremely dangerous. Our bodies are home to massive numbers of microorganisms, everything from bacteria and fungi to single-celled parasites. Most of these tiny life forms aren't harmful to us, and we live alongside them without any trouble. But if there were native organisms in Europa's ocean, meeting these Earth microbes could be catastrophic for them. The possibility of Earth's microorganisms spreading disease to other worlds is taken very seriously by space agencies. That's why every probe sent to distant planets or moons is always sterilized thoroughly before launch. And just to be clear, finding anything like a higher animal beneath Europa's ice is extremely unlikely. For evolution to progress, you need a wide variety of habitats and changing climate conditions, none of which exist down there. Plus, without sunlight, there's no photosynthesis, so the complex food chains we see on Earth can't develop either. In other words, this place has absolutely nothing that a large animal would need in order to survive. So if there is life in Europa's subsurface ocean, it's most likely to be primitive single-celled protozoa. If you enjoyed this video, we'd love it if you hit the like button and shared it on your favorite social media. Thank you so much for watching. We truly appreciate your time. Until next time, take care and goodbye.